So welcome to Chapter 8. This chapter is on circles, but in this first video we're going to review distance, area, and perimeter of some other shapes first. So after this section, hopefully you can find the area and the perimeter of the basic shapes, and we'll go over which ones we need to know. So we're going to go over three different concepts first: distance, area, and perimeter. And I think on your notes I actually call these A, B, and C. So this is what you need to write down for the first one, for distance. So distance is something that you measure with a ruler or a string or a measuring tape, something that's straight. Okay, write that down for number one. We're going to copy all these down and talk about them. Number two, distance tells us a length of something. How long is it? So if you're ever asked how long, then that's a distance. It's one-dimensional. It goes in one direction. As you can see from my picture here, if I have a straight line from here to here, that goes in one direction, and I would use something like a ruler to measure it. Okay, that's an example of a distance. So other examples might be how tall something is, or how wide something is, or even perimeter, right? If I'm measuring the distance around something, those are all straight lines. I'd measure each side as a distance, and then I just add them together. So perimeter is an example of a distance. And then the units we use: inches, feet, meters, yards, miles, centimeters, kilometers. All of those are examples of units for measuring distance. So we need to keep that straight from area. Area we measure with a square. So I don't use a ruler or a string anymore. I use a square. So here's my picture. If I wanted to know the the area of this whole thing, I would be asking myself, how much do I need to cover that entire shape? So I use squares. See my little squares here? I would say, how many squares does it take to cover this whole thing? That would be an example of finding the area. Okay, I can't use a ruler anymore. A ruler wouldn't cover this up. I have to use squares. So how many squares does it take to cover something? So it's two-dimensional now. I'm talking about going in two directions. I have to think about that way and that way to cover this entire space. So we say it's two-dimensional, 2D. So examples would be, how much grass is in your front yard, or how much carpet does it take to cover the floor, or how much paint does it take to cover the walls. And now, since we use squares to measure it, we have square feet, square yards, square meters, square centimeters. You can use the word square, you can abbreviate the word square, or you can use a little 2 like this, raised up to the second power, to show squared. So an inch squared would be 1 inch by 1 inch in a square. Or a square foot would be 1 foot by 1 foot in a square. Okay, that would be examples of units for measuring area. Then it's also important for you to know what perimeter is. So write this definition down. Perimeter is the distance around a shape. Okay, you know this before. You've studied perimeter before. So write down the hint just so you have it on your paper. It's adding up all the sides. Imagine if you were an ant and you were crawling along. How far would you have to go if you walked this entire distance, this entire perimeter around a shape? Add up all the sides. So in the square, I add up 4 sides. Or even if it's some random shape, I'd have to know all of these different distances, add them all together, and that total, all the way around to wherever I started, is a perimeter. So because perimeter is an example of a distance, or a type of distance, it's going to use regular units like inches, feet, centimeters. Okay? Okay, so here's 7 more examples. I need you to pick 3 of each. You need to add 3 more examples to your notes for distance and put 3 of them down as another example of area. Okay, I'll give you a second to read through them. Make sure you have 3 that you write down on your notes paper as distance and 3 as area. And then pause and we'll check. So amount of fencing around a garden, that's going to be a perimeter, which is an example of a distance. How far you drive, I would measure that in a straight line, like miles, kilometers. That's a distance. How big is your deck? I'm talking about like the entire space covered up with the deck. That's an area. How tall is your brother? I would measure his height with a yardstick or a meter stick. That's just a length. a distance, sorry. How big is your painting? If it's something, if I'm covering a canvas, covering anything is an area. How big is that movie screen? Same thing. If I want to know the area of the movie screen, thinking about both directions there. And then how wide is this room? If you would measure it with a ruler or yardstick, that's a distance. So make sure you have 3 of those written down, 3 more examples of each. Okay, before we move on to area of these different shapes, it's probably important to make sure we know what they are. We've already talked about triangles. You know, those are any 3-sided shapes. There's different types of triangles, but recognize if it has 3 sides, it's a triangle. Parallelogram, we've talked about that in Chapter 7 as well. Parallelogram, I have parallel bases and parallel sides. Okay. Rectangles, you know from elementary school, all right angles. These sides are the same and these sides are the same. And square, where all 4 sides are the same. And then trapezoid, we haven't talked quite as much about a trapezoid. In a trapezoid, I have parallel bases on the top and bottom, like that. And then just 2 other sides. Sometimes those other sides are congruent, equal in length. Sometimes these might be different lengths from each other, depending. But we need to be able to recognize the shapes for them. Oh, because we're going to review the area formulas for each shape. So, area of a rectangle. This is one you probably remember. If I wanted to find the area of this rectangle, most of us probably remember I would multiply this length times the width, right? 5 times 12. That would give me the area of that rectangle. These are inches. If you see that marking, it means inches. So this would be 5 times 12 gives me 60 square inches. Okay? Don't write this like that, because then people get confused and they think they're supposed to do 60 times 60 and then inches. That's not what that means. So I can either write square inches like this or like this. Okay? Okay, so area of rectangle. There's a spot for you to write this formula in your notes. Instead of saying length times width, that works, but that's a more elementary definition of it. We're going to change it and say base times height. So write this down in your notes, but then I would probably also write down the words base times height. That gives us the area of a rectangle. So I'm going to actually move this now and ask you, what do you think is the area of the purple triangle that's inside here? Well, if you notice, I'm just exactly cutting it in half. So the area of this triangle would be half as big. I would get an area of 30 square inches for that shaded purple part. Okay? Turns out that for any triangle, here's your formula. Area of any triangle is the base times the height, but then cut it in half or divided by 2. Some people will write it this way, base times height and then half of that, or 1/2 base times height. Those will all give you the same answer. We need to be able to find the base times the height, and then it's half as big as the rectangle shape. So base times height, and that would be half as big as this rectangle that it's inside of. Or base times height, and it would be half as big as the area of that whole rectangle. Doesn't matter what shape it is, it's always half as big as the rectangle that would go around it. So that's how you can remember the formula. So if they ask for the area of this one, I actually wouldn't be able to find it. If I don't know what this height is right here, how tall my shape is, I can't find the area. So it's pretty important to make sure you can find the base and the height in order to get the area. Okay? So for example here, I could use this as the base and this is the height. So sometimes the height is one of the sides of the triangle, but like in this example, that's the base. Here's the height, and it's not that side, it's not this side, it's not one of the sides of the triangle. It's something I have to draw in as an extra dimension, extra length to know. So, bases and heights. You have this copied on your paper. Do it with me really quick as we talk about each one. If I have a base, that's one of the sides of my shape, and the height has to be perpendicular to it. Okay? So again here, if I use this as the base, this could be the height that's perpendicular to it. But if I use this as a base, I'd have to draw in a height. I'd have to be given that extra information because I don't have anything else that's perpendicular to my base. So if this was a base, this is actually a parallelogram, so it's not quite straight. I'd have to know this perfect height that's perpendicular. This one is a rectangle, I think, so there's a base and there's a height that is perpendicular to it. Or here, if I have that base, actually I'd have to know what this height is perpendicular to it. So just be aware that sometimes the base, or sorry, sometimes the height is one of the sides of the triangle or shape, and sometimes it's not. Sometimes it's an extra line you have to draw in. So I want you to list the base and the height for each of these. We'll do one together and then you can practice. So for example, in this first one, if I say this is the base, A to C, base A to C, segment AC, and then this would be the height, so BD. If it's a segment between 2 points, we use the 2 letters on either end, and then we draw the line over the top to say it's the segment between them. Okay, so I want you to look at the blue, the green, and the red one and tell me the base and the height for each one. So pause and then we'll come back and check. Okay, here's the first one. I said that this would be the base and this would be the height, and they're perpendicular to each other. Sometimes you got to turn your head or look at the shape sideways. This one, here's the shape that I could use as a base, and I have a height that's perpendicular to it there. And then my final one, I have a base and a height, and those are perpendicular, so that will work there. Okay, so find the area and the perimeter of each one. You have these copied on your paper as well. Make space and make sure you find the area and perimeter. Let's talk about area first of this blue one. If I want to know the area, I have to know a base and a height. Looks like the only base I could use is that one. And the only height that I have that's perpendicular to it would be that one. So the area of this would be base times height divided by 2. So the base is 10, the height is 5, and cut it in half. So 5 times 10 is 50, cut in half. I get an area of 25. Okay, and then perimeter. Add up the 3 sides. So 6 plus 10 plus 15. Looks like I get 31. And I don't have any units here. I should, but I don't. So we'll just leave our answers like that. So you get to try the green and the red shape. Find the area and the perimeter. So in this one, I got a perimeter of 8 plus 5 plus 10. Gave me 23. And area, here was my base. Here was my height. And divided by 2, I got 20. And in this one, I actually don't have the height. I don't know that. So I actually can't find the area. But perimeter would be 8 plus 12 plus 15, and I got 35. Okay? I think there's a spot on your notes that say the area, or sorry, the base and the height have to be, what you want there is base and height have to be perpendicular. That's the important idea. Sorry if I skipped over that. Okay. So, we did that. Last shape here, parallelogram. So, here's our rectangle. We already know that. I know that I could multiply the base times the height to get the area of that. Well, I'm going to move this aside. So we know that area is base times height for that red shape. But what if I take this piece now, this triangle, and I actually move it over here? You'll notice that I didn't remove anything or add anything. I still have the same amount of area that I had before, but now this shape is a parallelogram, right? These sides are parallel, these sides are parallel. It doesn't have right angles anymore, but it's actually the same area. So it's still base times height. Doesn't matter if I put the height here or out here, as long as it's drawn in perpendicular to the base, right, in each of these, it's going to work, and I just do base times height. So you have 2 examples here. Go ahead and do base times height for each one. Find area and perimeter, and we'll come back and check. So here I did base times height, Got an answer for area. Added up all four sides to get an answer for perimeter. And same thing here, area and perimeter.